Let's say a group checks the price of eggs in at 10 stores in, let's call it region A. Group checks the price of eggs at 10 stores in region A, and here they are: 70, 68, 72, 60, 63, 75, 66, 65, 72, and another 65. Notice I wrote those in a line so I won't have to rewrite them, because guess what our first little question is going to be? Find the standard deviation, find the mean and the standard deviation of these prices, okay? So let me write that down here. Find the mean and standard deviation for these prices for region A. All right, well, the mean is, compared to standard deviation, is an easy one, isn't it? What's the mean? Well, you'd add, just add up all the values and divide by the total number of values there are. What do I got here? 70. Oh, let's do it. Okay, 70 plus 68 plus 72, 60, 63, 75, 66, 65. Where am I? 60. Y'all check me on this. 72 and 65. 676? Anybody else get that? For the total here? And we should divide that by what? Divide by the total number there are? There should be 10. Okay, 10. Which is going to give me 67.6. So that's my mean. Now I want the standard deviation, S. Well, I'm going to have to do a little calculating, and that's why I skipped the little space there. Because to do the standard deviation, I need to do the deviations, the values minus the mean, and then square those all across the board there, okay? Now, don't have to put them in order. You can if you like, but I don't want to recopy them, so the median is the only time you need to reorder them. I mean, a lot of times we like them in order, but it doesn't have to be in order, no. Now, the other point I was going to make, computers can do this very, very accurately. But do them by hand. I mean, we could leave it in decimal form, because I'm going to have to subtract the mean from all these. So that if I leave it 67.6, I'm going to get all these decimals, right? Why don't we? Wouldn't 68 be a nice rounder number there? Let's call it 68. Let's round it off.
Then if you put them in order and you divide it, it wouldn't be.
Okay. All right. Yeah, so if you get a decimal mean and you're doing the standard deviation, I would just round it off to a whole number. That'll be fine. Okay. Okay, so what's the deviation for 70? Well, I'll just take 70 minus the mean. I called it 68, so that's going to be 2. 68, I take the mean minus, so that would be 0. 72 minus 68, that's 4. 60 minus 68, that's negative 8. 63 minus 68 is negative 5. 75 minus 68 is 7. Negative 2, negative 3, 4, negative 3. Check me on those. Did I get those right? Does anybody believe that? So far, so good? Okay. All right. Well, now go and square those, right? Square them. That would be 2 times 2 is 4, 0 times 0 is 0, 4 times 4 is 16. Negative 8 times negative 8, positive 64. Negative 5 times negative 5, 25. 7 times 7 is 49. 4, 9, 16, and 9. So far, so good. Believe that? All right, so now I'm ready to go for standard deviation. I'm going to take the square root then. I'm going to add up all these 10 numbers here. Which I'm going to get, if I add those up, 4, 0, 16, 64, 25, 49, 4, 9, 16, and 9. I get that to be 196. Does anybody else want to believe that? 196. So all told, that's what those all come out to be. Now what am I going to divide these by? N minus 1. Divide by n minus 1, which now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values still. So I'm going to do 10 minus 1. That's 196 divided by 9. It's 21.77777. Keeps repeating. And so we take the square root of that. It's about 4.67. Standard deviation, 4.67. Question or concern? Is this good? Is that okay? All right, so notice that was my number 1 question. I've got a couple others on this one. All right, let's just, all right, so region A, get rid of the, so here's the region A. We've got the mean is 68 and standard deviation 4.67. If in region B we have, if region B has a mean, x bar, of 70 cents, let's say that. If region B has a mean price of eggs 70 cents and a standard deviation of 2.01 cents, answer the following. So these are going to go with A's. Data. Save you a little work there. I'm already going to give you the mean and the standard deviation. Somebody calculated that one for us, okay? Or I made it up. All right? So answer the following. Number 1. Which regions prices were more dispersed? Which regions' prices were more dispersed? Well, that was another reason for not giving you the data for B. We know data for A, and If we had the data for B, maybe we could eyeball it in, but I don't know that we could since they have 10 values there. Anyway, they're harder to compare the more values you get. However, we have a measurement that tells us about dispersion, don't we? What measurement tells us about dispersion in statistics? Standard deviation, right? Standard deviation tells us about dispersion. Okay, so which one, based on that little observation, which one of these regions, A or B, had more dispersion in their prices? Well, B has 2.01. A has 4.67 standard deviation. So which one is more dispersed? A's is more dispersed. Region A's prices were more dispersed. Why? Higher standard deviation. It had a higher standard deviation. With me? That's what standard deviation measures. It measures dispersion. These on average, if you will, average being away from the mean 2.01. These average being away from the mean 4.67. So the values were further away from the mean on average than B's were. Okay? You with me? Number 2, which region's prices had a higher average? Had a higher average price. Maybe a little easier question. Which measurement tells me about average? Which measurement is average in statistics? The mean's the average, right? Yeah. In statistics, average equals the mean. So if I'm looking for the higher average price, I'm looking for the higher mean. Which one has the higher mean? A's mean is 68. B's mean is 70. B has a higher average price. Higher mean. Yeah. So it would ask you for average, higher average, lower average. You're looking at the mean. 70 cents compared to 68 cents. Okay? Got one more for you. Which region's prices were more consistent? We haven't talked about consistency. However, it's highly related to something else we've talked about. Let's think about consistency. Wouldn't, if I said the values are more consistent in this group as compared to this group, they're more consistent, wouldn't that mean they're more closely, tightly bound together? You know what I mean? These are more consistent than those. These would be closer together. So in other words, if it's more consistent, I could spell it, more consistent, wouldn't that equal less dispersion? More consistent would mean they're closer together, which means less dispersion. With me? Consistency means less dispersion. They're not as spread out. If something's more consistent than something else, it's less spread out. Okay? So if I had, 1, 2, 3, And then I had 1, 16, and 50. Which ones are more consistent? It's those, right? Because they're closer together. They're not as dispersed out. So more consistency equals less dispersion. Well, what does that mean as far as our measurements are concerned? What tells us about dispersion? Standard deviation. So less dispersion equals lower standard deviation. So having said all that, which region's prices were more consistent? You tell me. B's are more consistent. Why? Its standard deviation is 2.1. A's standard deviation is 4.67. So B's are more consistent because they're less dispersed. And less dispersed means more consistent. So if it asks for more consistency, you want less dispersion. Make sense? So B. And that's because less dispersed means more consistency. Well, here's what I mean. B, because it has a lower standard deviation, which means it's less dispersed, which means it's more consistent. That's the reason.